to have you again this morning, and we have a very interesting topic to look at. And the topic we are going to be considering is, first of all, redox reaction. Then we'll go into stoichiometry of reactions, and I believe you are really going to learn a lot. So just make your mind ready to learn as we take on this journey together. Now, redox reaction. Basically, what we'll be doing this morning is to solve some ranges of questions under balancing of equations under redox reaction. But before we go into that, it is good you understand what redox reaction is actually. So that is going to aid your understanding of the topic. Now, when we say redox reaction, we are saying that the kind of reaction where oxidation and reduction take place simultaneously. I don't know if you get what I'm trying to say. That is, as oxidation is taking place, reduction is taking place likewise. So that's basically what redox reaction is all about. And therefore we can say redox reaction can be broken down into two. We can say we have reduction and we have reduction and we have oxidation. Alright, we have reduction and we have oxidation. Now, we have to look at the various meaning of reduction, so that in any case when you come across them in your exam or when you are reading your textbook, you should be able, so that you're able to identify them. So, and that is what I am doing next. Now, I have been able to tell you that redox reaction is basically reduction, reaction and oxidation put together. So you have your redox reaction. Now, reduction can be viewed in from many point of view. The same way with oxidation, it can also be viewed from different angles, and these angles are what we are going to consider right now. Now, the one that is very obvious for most of you, let's start with oxidation. Oxidation is, first of all, we know oxidation is addition of oxygen. That is, when you add oxygen to a reactant, you are saying that you have carried out oxidation. Alright, another word that's another way of defining oxidation is loss of hydrogen. So when hydrogen is lost in a reaction, you are able to you are sure that oxidation has taken place. Alright, the next thing is increase in oxidation number. Oxidation number or oxidation states of an atom. So by this, you are also sure that oxidation has taken place. That is, whenever the oxidation state or oxidation number of a species changes from the value where it was before and have an increase in it, so you can say oxidation has taken place. Another way to look at oxidation is increase in number of electronegative atom. Example of electronegative atom, you have your group 7 element. Basically, you have your chlorine, you have your fluorine. Oxygen is also an electronegative atom, and the likes. So when this happens, you say oxidation has taken place. Alright, oxidation has taken place. So oxidation could be seen as addition of oxygen, loss of hydrogen, increase in oxidation number, oxidation state of an atom, and increase in number of electronegative atom. I believe you understand that. So the next for us to look at is reduction. Alright, reduction is just the exact opposite of what oxidation is. If oxidation is addition of oxygen, you should know that reduction is you are taking away oxygen. That is, you are reducing oxygen. You are looking for a way of getting rid of oxygen. Alright, if reduction is loss of hydrogen, therefore if oxidation is loss of hydrogen, therefore reduction is going to be addition of hydrogen. All right, if oxidation is increase in oxidation number or oxidation state of an atom, automatically reduction is going to be decrease in oxidation state or oxidation number of an atom. If oxidation is increase in number of electronegative atom, therefore reduction is going to be decrease in the number of electronegative atom. So by this we have been able to look at least 4 ways in which oxidation could be defined. And the reason why I am taking the pain to do this is when we get to what you have to do for the day, we are going to be needing that knowledge there, particularly the knowledge of oxidation and reduction as increase in oxidation number and decrease in oxidation number respectively is going to be needed today. So I want you to just lay your lay a grip on particularly this third definition, that oxidation is increase in oxidation number or oxidation state of an atom, and reduction is going to be decrease in oxidation number or in oxidation state of that atom. So that settles the definition of oxidation and reduction. Alright, so like I said earlier when I began with you, I said redox reaction is a kind of reaction where oxidation and reduction takes place simultaneously. That is, as one species is being oxidized, the other is being reduced, and therefore you have your redox reaction. Fine. Now, we have some set of equations here to balance. Over the time, we have known that students, when you give them a molecular equation, they can just go ahead and balance it in the twinkling of an eye. But when it comes to redox reaction, it poses to them some kind of difficulties, and that is what I have come to deal with this morning. So please make sure you pay a very good attention to what we are going to be doing. Alright, now when we are talking about balancing redox reaction, one thing you must know is that when you are balancing redox reaction, you have to pay a very good attention to the medium in which the reaction is taking place. Now, what exactly do I mean by the medium in which reaction is taking place? The medium is that environment, and this environment can either be acidic or it can be basic. It can either be acidic or in a basic environment, and having the understanding of whether it is acidic or basic environment is going to help you to really know what you are required to do, because they have different methods. We have different ways of balancing redox reaction. When it comes to acid medium and basic medium, we don't balance them the same way. That's what I'm simply trying to say. All right, so that's the basic thing you should understand about that. I remember in one of the contacts I have with you, I solved the question on balancing redox reaction in acidic medium, but I'm not that sure I do have time to break it down. So I want you to pay attention and focus. Now, we have 2 questions on acid medium and we have 2 questions on basic medium. So and we are going to start with the first, which is acid medium. Now we are to balance Alright. We have 2 questions here, and the first question is this. Your ion 2 ion Okay, so I already put acid medium there. There's no point putting it in front of the question, because all that we are going to be starting with is acid medium. And when you look at this, you can realize that this is a species here, this is another species. And when you look at here, we have some other 2 species here, and you realize that on this side of the equation of the reaction, you can realize that the charge that this is bearing, don't forget that oxidation number of atoms in their natural state is 0, of course. And when you look at ions, now how do you know the oxidation number of ions? You look at the charge on them. So you can say that the oxidation state of this here is just 2. Now what you can see here is that what does that oxidation of this is 2, and when it gets to the right hand side of the equation, it has increased. Now, from the knowledge of what I explained about oxidation and reduction, you should know that what has happened is that this Fe2 plus has been oxidized to Fe3 plus. That's basic enough for you to understand. Alright, so it means we have ion 2 here, of course, but now we have ion 3. Therefore, you can say oxidation has taken place here. Now, let's come here. What you have is MnO4 minus. Alright, so when you look at the oxidation number of manganese here is what? Now let's try and calculate the oxidation number of manganese here. Alright, the oxidation number of manganese here is manganese plus the oxidation number of oxygen normally is -2. So -2 multiplied by 4 will give you -8. Alright, now everything equal to the charge you have here, and that is -1. Now when you have this, you are going to have your Mn to be, when this comes to this side, becomes 8 minus 1, and you have it to be what? To be 7. So it means the oxidation number of manganese here is 7. But when you get here, what is the oxidation? You have it to be 2. It means reduction of oxidation number has taken place. Therefore, that's simply reduction for you. So that's one of the ways I have defined oxidation and reduction for you when I started this class with you. So just relate that knowledge with what is happening here, and you are going to get what I'm trying to pass across. So now we believe that this has been oxidized while this has been reduced, and we are sure that this is a redox reaction. Now that's the first thing you have to identify. Identify that species that is undergoing oxidation and the one that is undergoing reduction. Therefore, that leads me to the steps involved in solving these equations. That are steps involved in balancing redox reactions in mediums, or in different media rather. So we have your first step is identify the species undergoing oxidation and the one undergoing reduction. In other words, I'm saying break the equation into half cells or half reaction. Now, if you are going to break this into half cells or half reaction, what are you going to have? You are going to have your Fe2 plus to Fe3 plus, and you have your Mn04 minus to your Mn2 plus. So you know oxidation has taken place here and reduction has happened here. So simple as that. Now, after the first thing has been achieved, the next thing is we are going to balance atom and we are going to balance charge. Now, when we are balancing equation of equation in acid medium, I mean redox reaction, what happens is that you balance atom and charge, like I said earlier, and the atoms you are balancing are oxygen and hydrogen majorly, and you are balancing the charge. Now, whenever you want to balance charge, you just balance charge with electron. Whenever you want to balance charge, you balance the charge there with electron. Now, concerning the atoms, there are some rules that must be followed. So I'm going to make that clear to you now. So whenever you are balancing atom, oxygen must be balanced in a certain way and hydrogen balanced in a certain way, and the different way by which you balance them differs, no, relative to the medium in which the reaction is taking place. All right. If you are going to balance oxygen atom, you balance oxygen atom with 1 mole of water. That is 1 mole of oxygen atom. You balance it with 1 mole of water on the deficient side. And whenever you are going to balance hydrogen atom, you balance 1 hydrogen atom with 1 hydrogen ion also on the deficient side. So far, the reaction is taking place in an acidic medium. I will take that again. Balancing of that atom requires you to balance 1 oxygen with 1 water, 1 mole of water on the deficient side, and you are balancing 1 hydrogen atom with 1 hydrogen ion as well on the deficient side. That way you are really going to get what you are required to provide in the question.